All right, in this video I'm going to talk about nonmetals, sort of the opposite of a metal. This one has a high effective nuclear charge and a large amount of attraction between the atom and the valence electrons. So our example here will be oxygen. Oxygen has an atomic number of 8 and an atomic mass of 16, meaning that it has, here I'm going to switch pens here. It has 8 protons and 16 minus 8, 8 neutrons. And it has 2 electrons in the first shell and 6 electrons in the next shell. I'm just going to shrink this down a little bit. There we go. Okay. So we'll just look at it from this electron's point of view, one of the valence ones who's going to be looking in and seeing how attractive this nucleus is. It's going to take this entire central part and treat it as if it's one object with 8 protons and 2 inner electrons, so 8 minus 2, or an effective nuclear charge of 6. And so from a chemical reactivity standpoint, this atom really looks a lot more like this, plus 6 with 6 valence electrons. Now one more time, the effective nuclear charge ranges from +1 to +8. So +6 over here is a attractive nucleus. What that means is if there was a metal, someone like lithium with its +1 and its 1 electron, then he'd be able to steal that electron from lithium. And so nonmetals react by gaining electrons from nonmetals. This leaves them with extra electrons. And as a result, they form negative ions. When forming bonds with other nonmetals, what they end up having to do is share their electrons with their neighboring nonmetals. So they have to share, see they have a common space here where they share electrons between them. And to understand the overall properties that happen when this happens, instead of a transfer of electrons but a sharing of electrons, we need to get into a whole bunch of complex factors about the actual shape of the molecule and a bunch of other stuff. So for the point, for our purposes right now, that's what a nonmetal is: high effective nuclear charge, very attractive to electrons, holds its own electrons, maybe steals them from metals if they're around, or if it has to, if there's no metals around, then it can share them with other nonmetals. We can't really get into factors of this. We're going to spend a bunch of time later on videos about polar, covalent, and dipoles and molecule shapes and stuff like that. When we get there, we'll talk about why these atoms behave the way that they do. But we're just not in a place to talk about that right now until we've learned a bunch of other stuff. So nonmetals, that's what they are.